and speaker Dr. Suresh Akilla, Professor and Dean of Research and Development, Shreyas Institute of Engineering and Technology, Hyderabad, Dr. G. Venkat Subbaya, FIA, Honorary Secretary, II, Telangana State Center, Engineer K. Subbareddy, FIE, Committee Member, the Institution of Engineers, Telangana State Center, and convener of today's event, past chairman, past presidents, past honorary secretaries, council members of IEI, members of Telangana State Center Committee, corporate members of IEI and Telangana State Center, distinguished guests, representatives of media, ladies and gentlemen. Today, I feel it is a great privilege and honor to be among this August virtual gathering and extend a warm and hearty welcome to the today's chief guest and speaker and all of you to this National Technology Day on design and development of refrigeration systems for sustainability under the theme of integrated approach in science and technology for sustainable future. Today, I am very happy to be associated with this memorable event. I am glad to inform that the Institution of Engineers India is the largest multidisciplinary professional body encompassing 15 engineering disciplines with about 8 lakh membership and also gives engineers a global platform for sharing professional interest and information. The Institution of Engineers India was established in the year 1920 with its headquarters at Calcutta and incorporated in 1935 by the Royal Charter. It is the only professional body in India accorded this honor and serving the engineering fraternity for more than a century. Today, its quest for professional excellence has given it a place of pride in almost every technical, prestigious, and relevant organization across the globe. It also provides a vast array of technical, professional, and supporting services to the government, industries, academia, and the engineering fraternity. Operating through 125 centers located across the country and 6 overseas chapters. Besides, the Institution of Engineers India has bilateral agreements with about 31 international bodies and a membership of another 8 international bodies of the developed nations across the globe. And I am also glad to inform that the Telangana State Center is a legacy of Restwhile Nizam's Hyderabad State Center, which was formed on 28th August 2016 after bifurcation of the combined Andhra Pradesh State Center. It has more than 9,570 corporate members on its rolls and about 19,000 plus as non-corporate members. It is one of the most active centers of the Institution of Engineers India, which engaged successfully in translating the objectives and mission and vision of the Institution of Engineers India into practice. And our state center has bagged Best State Center Award for 2 consecutive years from 2018 to 2020. The Telangana State Center has been playing very important role in dissemination of information on engineering and contemporary technology, bringing industry, academia, experts, professionals together on the same platform. And today, the 11th May is observed as the National Technology Day all over the country. This day marks the anniversary of Pokhran nuclear tests, which made in the year 1998, and India's technological advancements in this space. Pokhran nuclear tests were a series of 5 nuclear bomb tests explosions conducted in India at the Indian Army's Pokhran test range. On May 11, 1998, India successfully fired Operation Shakti missile at the Indian Army's Pokhran test range in the state of Rajasthan. The first among the first nuclear tests in Pokhran, the test was led by aerospace engineer and the late President Dr. APJ Abdul Kalam. Later, the Prime Minister Atal Bihari Vajpayee declared India a nuclear state, making it the sixth country to join the nuclear club of nations, and hence, and since the year 1999, May 11 is celebrated as National Technology Day in India. The National Technology Day is celebrated to highlight the achievements of engineers and scientists in the field of technology and science. The day acts as a reminder of the country's technological advancements in the field of science and technology. On behalf of the Telangana State Center of the Institution of Engineers India and on my own behalf, I once again extend a hearty welcome to the chief guest and speaker, Dr. Suresh Akilla, Professor and Dean of R&D, Shreyas Institute of Engineering and Technology, Hyderabad, and all of you to this important day of the event. Before I request Dr. Suresh Akilla, the professor, so I request today's convener of the event, Engineer K. Subbireddy Garu, to kindly introduce the our chief guest to the audience and then proceed and over to Sri Engineer K. Subbireddy Garu. Thank you, sir. Thank you, one and all.
Thank you, President Garu. Before going to the brief resume of Dr. Akilla, I want to add some of the points of the President's speech from earlier. As the National Technology Day is one of the most fortunate days in Indian history. The Government of India commemorates its presenting honors to those who have made significant contributions to the growth of technology. Technology plays an important part in our daily lives. And when we consider its contribution to economic growth, National Technology Day becomes crucial. It is a day to remind Indians of the country's technological advances. Technology helps us stay organized, connected, healthy, and safe. Technology increases productivity and provides us with new insights into how the world operates. National Technology Day has a significant historical importance in India. The day commemorates, of course, we have already explained by our President. The day commemorates as an achievement of India's technical advance since on May 11, 1998, the country successfully tested nuclear weapons in Pokhran. Every year on this day, officials pay honor to India scientists for their achievements. We can all agree that technological growth is affecting the country's livelihood and status. National Technology Day is observed in India to honor the remarkable hard work and achievement of Indian scientists. So with these two words, I will go into the brief resume of such a great person, Dr. Suresh Akilla. He has his undergraduate degree in mechanical engineering from Usmania University in 1978 and obtained a master degree in design and marine dynamics from IITM in 1980. Machine dynamics. He pursued his interest in FEM and numerical simulations and obtained his PhD from the University of Alberta, Canada in 1984, where he developed Timoshenko beams and shafts to model turbine shaft vibrations and balancing. He is a President's Award receiver for NSS service from the Institute in 2019. He joined in air conditioning compressor manufacturing company in 1985 and continued up to 2008. Sriram Refrigeration as continued in 2008. That is a company Sriram Refrigeration as R&D and quality heads. The company was taken over by an American MNC, Tecumseh Products, in 1997. He developed an AWPQ quiet compressor, which was the company's lifeline, which was the lifeline of the company for about 20 years until rotary and scroll compressors gained importance. From 2009 to 2010, he was technically heading Denson Hydraulics for hydraulic and pneumatic equipment. He built a semi-anechoic remove for assisting compressor model testing and air conditioner testing. He developed a calorimeter lab, reliability lab, and customer care center. He has published more than 50 papers in international and national journals and conferences in the area of noise and vibrations, R&AC, and compressor designs. He also helped local universities, that is JNTU, H, and Osmania University, with their UG, PG, and PhD projects. 4 PhD doctorates were awarded under his guidance. He has 3 patents to his credit. As a quality head, he was involved in TQM, ISO 9000, ISO 14000, and UL certification. He is BVQI certified lead assessor, was involved in 6 Sigma activities, especially in SQC and process and product optimization. Used Teguchi methods both off and online. He was BOS member for ME and JN2H, ME for JN2H, Vignan, and RGKUT. He is a member of IIE, NVSI, IAW, and ISHRE. He completed a 25 lakhs project for BRFST for welding analysis using ANSYS and Abacus in 2015. Established a psychrometric test lab under MSME support systems at SIAS Institute to develop R&AC products. Manufacturing patented mobile air conditioner, SMAC, first one of its kind in India. He has given technical consultancy to HBL to indigenize rotary compressors manufacturing. He is developing a cooling system for a multinational company for electrical vehicle devices, designing an industrial oven for exothermic sleeves, ducting for ML and A building cooling. He is at present Dean and R&D at the SIAS Institute of Engineering and Technology, affiliated with JNTU Hyderabad. He is the chief editor of SIAS International Journal for Scientists and Technocrats. He has visited Canada, the USA, Japan, China, South Korea, France, and Dubai for his research work and presentation of papers at the conferences. His interest in modeling and manufacturing continues. As a great person, Dr. Akella, I am presenting to the audience. Thank you very much, sir, for giving the opportunity for me to introduce you such a great person. Thank you, President. Sorry, thank you.
Thank you very much, sir. You have enhanced my image very much. Thank you very much.
Sir, may I request the chief guest, sir, to kindly proceed with your address, sir?
Is the presentation visible, sir? Hello? Is the presentation visible?
Yeah, it is visible, sir.
And am I audible also?
Yeah, you're audible, sir.
Okay. I'll present today. First, I thank the organizers of the Institute of Engineers to give me this opportunity to talk about the work I have done and also related to sustainability. And I thank Chairman Brahma Reddy Garu, Convener Subba Reddy Garu, Secretary Venkata Subbai Garu, and all the professors, Ramna Nayak Garu, and JN2H Professor Gupta Garu. They have been very good close friends, and other professors who are also attending. I thank all of them. And my speech will be sustainability and how it is related to the work I have been doing for about 8 years in introducing students to R&DC and the relevance of R&DC in this sustainability. These are the areas I'll be covering. Sustainability is, these slides are borrowed from net, meeting the needs of present without compromising the ability of future generations to meet their own needs. We understand very well when we have, in terms of money, when we earn money, we spend it for ourselves, for our present needs, and also we deposit some money for the future of our development of our generations, maybe next generation, or sometimes the second or third generation also people understand. So they understand the importance of money very well. But we are living because of the 5 elements of the nature: air, water, earth, energy, which is fire, and sky, which is environment, and mind and its being. Why these are important, we are understanding very well now because of the COVID effect, where nature is replying to the misuse of humankind, and Arctic ice is melting, the water is rising, some of the islands will disappear, and there are unforeseen heat waves, storms. So many things are happening because nature is losing its balance, and we have to avoid this. Just like we give importance to money in our life and the life of our generations to come, similarly, environment is so important that at least they should be able to live, if not enjoy, at least they have to live. And the onus is on us, the present generation. And when we say sustainability, we have to bring economy, society, and environment, all these 3 factors into harmony. They're all related, and how they are related means if the planet is, nature is well kept, if you have very pure air, if you have pure water, like today, we are all buying water. So unfortunate. And we know that we are breathing polluted air. And environment is bad means your mind will be polluted. You'll be stressed easily. And to avoid that, we have to first sustain our earth and all the 5 elements of the earth. Once we do that, when the mind is healthy, it will operate at its most optimum value, and earning prosperity is not a big deal. So whatever we say that we earn for our first generation, second generation, third generation, fourth generation, that will happen. And people will be happy, the families will be happy. Otherwise, the stress is breaking families. From joint family, it has become to disjointed families. From disjointed families, it is becoming diverse families. So all these things reflect very badly on the society also. So the onus, the first point is to make sure that we have earth which is very healthy first, and the responsibility is ours. From mechanical point of view, if we look at the lithosphere, which is the top layer of the earth, it has to be maintained well. And recently, Jagadguru Vasudev Garu, he has taken a international lead in saying that earth will not survive for more than 50 years the way we have treated it. And there will not be food to eat also. Now we don't have a air which is non-pollutant. We don't have water which is non-pollutant. Tomorrow we'll have earth which cannot give us nutritious food. Already we are seeing that effect. Today, whatever food we are getting is from the chemically managed, chemically managed. So we are not very healthy. Is it audible, sir? Any problem?
Okay, sir.
Okay. So sustainability is keeping all these factors of life together, and nature interacts, like earth also interacts with this. So there are some open systems with energy, like sun is giving heat and light to us, and because of the photosynthesis, life is going on. Both animal life and human life is there because of that. But this is a open system, so it's a one-way travel, one-way giving of sun's energy to us. But there is a biosphere which is a closed system. We have nothing disappears. Like everything will disperse. Like it will come back to Earth. All the biomatter will come back to Earth, and then it will go back to the nature. So this cycle is a very healthy. Nature formed its own variety to give good sustained life to us. We should not disturb, and we have the responsibility to retain it. And with respect to my presentation, this slide is important because how refrigeration air conditioning becomes a part of sustainability. So if we look at the efficiency point of view, all the resources we are getting, we should be using them effectively. Like just because we have money, if I spend the money non-judiciously, then the money will be lost. When I want it for a purposeful use, I will not be left with any money. Similarly, when we have resources like petrol or trees, coal, all the natural resources, if we don't use them effectively and judiciously, a time will come, maybe 30 years, 40 years, 60 years, 100 years, when all this will disappear. When we want for the future generations, it will not be there. And also we have to manage the resources properly. And they have to be managed so that the ecosystem doesn't get disturbed. So with respect to the refrigeration air conditioning, we have to, the compressor is the main part which will take energy from some source. Today we are getting electricity from our thermal plants, or from hydraulic is good. Hydraulic is so we have to see whether it's renewable or non-renewable. Otherwise, we have to create some more like solar energy or wind energy or nuclear energy, geoenergy, and ocean energy. So there are so many renewable energies which are possible. We have to look at, and the nation and the world is looking at these aspects. And from compressor point of view also, we have to look at any possibility of using these proper renewable energies. Then high energy applications. The Bureau of Energy Efficiency organization is looking at these aspects, and they have put proper rules how we have to improve our energy efficiency year on year according to the standards given by them. So this comes under this R&DC field also. Eco-friendly refrigerants, like we'll be talking about ozone depletion and greenhouse effects, and Montreal Protocol and Kyoto Protocol have removed some of the refrigerants which should not be used because they'll be spoiling the ecosystem. In academia, we talk now of Bloom's taxonomy level, that there are levels of learning. If we are learning a new subject in an institute as a student, we have these 6 levels called remember, understand, apply, analyze, evaluate, and create. in industry also, or for a scientist or for an engineer or a technocrat, these 6 steps are also same common. Like first we have to understand whatever we have learned, the basics and the standards which are formed by the nation internationally, how to remember them so that we don't miss the basics. Then we have to understand the theoretical and competition which is coming. According to Elon Musk, this second one is the most important. Whatever he's creating, he's looking at this part, whether theoretically all his products are answering or not, and whether they're meeting competition, and then they're the best in the competition. So unless this passes the second step, he will not approve any of his products. And to me, he is like God. Technology God is today to me, Elon Musk. Of course, everybody have their own. And the natural steps which all we offer, no, we have to design and develop skills for the building the products, analyze, that is, test them, see whether the specifications are met, and then evaluate. And if they're not met from quality point of view or production point of view or from customer needs point of view, we have to create some new changes. All these are the steps which will follow, and this also is the same what we teach to students in Bloom's taxonomy. And if you go to air conditioning, most of the engineers will know the basics. I'm just recalling. Window air conditioner is what we have. I said I started my career in Shriram Refrigeration. At that time, only window air conditioners were there in India. Usha was making, and also Feathers were making, Voltas were making, some very few players. And window air conditioners in 90s were taken over by split air conditioners. And today only split air conditioners, because the noise is raised less, and the noise and heat of the compressor is thrown out. Then came some package units which are fixed in the corners of big malls or offices, where the hot air is sent out to a panel, and the condenser and evaporator are in the same form. Based on this system, I have developed the mobile air conditioner. These are there internationally, but India there was no design and nobody was manufacturing. We were importing some mobile manufacturing units from outside. Here it is similar to the package unit. Only the heat is not dissipated from a point. It is not ducted out. It is having a hose pipe, and the hose pipe will carry it out of the window, or it will take it out of to the next area which is not in the purview of your cooling. And this is what the product we have developed. And coming to the basic air conditioning cycle, all of you know that there is an evaporator which takes the heat from a room which is to be cooled. That heat is sent to the higher pressure and temperature of condenser through a compressor, which is the work done. And this hot gas is again cooled at the condenser, and then it forms into liquid. The liquid is throttled through the evaporator and then through a expansion valve and sent to the evaporator. So these are the different processes and cycles. In a window air conditioner, the condenser goes out of the window. In a split air conditioner, the condenser and compressor, they go out of the window, out of the wall. Inside the wall, there is a inside unit, and outside the wall, there is an outside unit. So the condenser and compressor goes out. Whereas in a mobile air conditioner, we keep the condenser and the evaporator in the same unit inside the room. So the heat in the room will slightly go up because there are two machines, like compressor is also working inside the room. It's not very efficient compared to a split air conditioner, but the advantage is just like a fan. If you have a very big room, if you have one fan and you are sitting under the fan, you are cool. So this is space cooler. Similarly, the mobile air conditioner is a space cooler. In a very big room, instead of putting a 5-ton AC or a 3-ton AC, nowadays, drawing room, dining room, kitchen are together, they require 3-ton AC. So it will be very expensive. You require about 4 units of power every hour. Whereas if I use a space cooler, about 0.75, 1 ton or 1.25, then the space which you are sitting in the dining room or drawing room, you can use it. So the purpose of developing this and the need identified was that. And coming back to sustainability, we have been training students, and our student made a solar tree with wind generators. So 3 wind generators are there and 3 solar units are there. Heat can be generated from this and used for some energy purpose. So the same unit can be used because it will give about 150 watts. A small refrigerator can be run, or you can use the power of for a household application. So we can get solar or wind or any other form of renewable energy which will run the compressor. The compressor is the main thing which will take the power, and we can find out alternate sources of energy. Presently, we are using the energy from the electric source which we get, which is 50 hertz. So what I mean to say is the whole cycle happens very fast. The compressor is running at 50 hertz, means 1/50th a second, the compression is over. And within a very small duration, maybe another 1/50th of a second, the whole process of condensation, expansion, again, evaporation, all that is happening. So it's a very fast process unless you imagine yourself as the refrigerant going through this process. Then there are different processes which are there, which are assumed to be ideal. And any deviation from the ideal situation is a waste, which is a loss. So we have to look at the losses, like if the expansion is not straight, if it is going through, then this much energy is wasted. A2 energy is wasted, which should be actually used for taking the evaporation heat, but we are losing that heat to the losses. Similarly, when the compression is taking, it should happen from 1 to 2 dash, but it goes to 2. So this triangle 2, 2 dash, 2 double dash is a waste energy. Like that, at every process, there could be wastage, which we have to reduce. As we said, sustainability means we have to, whatever we have to do this because it's a need of the society, but do it efficiently so that your BE rating is better and your star rating is better. So that's one thing we have to understand. Then a little bit about different appliances. There are deep freezers called low back pressure units, LBP units, we call refrigerators and deep freezers from there. Water coolers, display units, we call them medium back pressure units. And air conditioners, we call them high back pressure. So what happens is the same thermodynamic cycle is applicable to all of them. Only the evaporated temperature will be varying. So a deep freezer refrigerator will be operating at a very low evaporating temperature. The medium back pressure will be operating at a medium temperature. And like the low back pressure might be minus 20 degrees for refrigerator or deep freezer. And medium back pressure might be minus 5 to plus 10 degrees. Whereas for the heat exchanger, we have a minus 7 degrees as the heat exchange evaporator temperature required. So these are the temperatures demanded by the appliance. Similarly, the condenser is about 55 degrees. If it is less than 55 degrees at hot temperature, when temperature goes up to 46 degrees centigrade, the differential temperature will not be enough for heat transfer. So these are some of the aspects from the thermodynamics point of view, where we have to improve our efficiency called EER, energy efficiency ratio, or the quotient of performance, COP. These are some of the factors which involve current, power, all these factors. Noise is very important, vibrations, aesthetics is important, service day life is important. These are the aspects which are important for a air conditioning or refrigeration equipment. So as I said, we should understand what is EER. It is the heat removed per hour by power consumed. And COP is also same, but here the units are different. EER will use a BTU per hour per watt, and COP will use a watt per watt. And these are the different things. And the law of thermodynamics and heat transfer says that heat can flow only from hotter area to cooler area. But in air conditioning, what we want, when the room is cooler than the outside temperature, we want the heat to go from the cooler temperature to outside hot temperature. How is it possible? We have to do some work. That work is done by the compressor. And if the work is transferred to renewable energy, solar energy, that will be more beneficial for sustenance of the earth. We talked about the energy requirement. Now, another important factor which is important for sustainability is the ozone depletion. What is ozone depletion? Means in the stratosphere, with about 20 to 30 kilometers from the Earth's surface, there's a layer of ozone, O3, and all the halogens like chlorine, fluorine, and these halogens, they interact with the O3 ozone, and they decompose to oxygen, O2, and the chlorine oxygen molecule, under the presence of sunlight, photosynthesis happens. Again, a cycle which is going to happen for 20 years, 25 years continuously. So it's unstoppable. This was discovered in 87, and Montreal Protocol understood, and they have started putting some restrictions to the world in the usage of the refrigerants. So first they banned R11, then R12, and finally R22 will also be banned. They are giving more time because there is an improvement. Another important factor is the greenhouse effect. We all understand to some extent what is greenhouse effect, because we see there is a green net, and under that the plants can be grown even in cold temperature. So in a cold temperature, like say Norway or Canada or some kind, if I have a greenhouse, the heat is coming in ultraviolet rays, but it is staying inside the greenhouse, the green net. And after the earth or the plants take this heat, they reflect, they give back heat at a lower frequency. So the lower frequency waves, they will not go out of the greenhouse, the green top which is there. And what happens is, the inside that greenhouse, the temperature will rise, and then it will come down to a temperature where it is the life of the plants can happen. The same effect is also happening in the earth. The earth's surface is having all these gases which form a greenhouse net. Under the net, the ultraviolet rays, high frequency rays are coming down, and earth absorbs them, and earth reflects the low frequency waves which cannot go out of the greenhouse layer of gases. Then what happens? The earth's surface will have higher temperature and it becomes livable. Why we are living and we are having a comfortable temperature all over the world between 23 and 50 degrees centigrade? This is because of the greenhouse effect, which is good for the living. But over formation, like the carbon dioxide or sulfur dioxide or nitrous oxides or even O3, these gases make the greenhouse more and more strongly protecting the waves of coming from the earth, and the temperature of the earth can rise. And some of the refrigerants which we use also help in destroying our greenhouse effect. So we have to make sure that these two things are taken care of, ozone depletion and greenhouse effects are taken care of. And as I said, energy effectively and efficiently using is very important. And luckily, Bureau of Energy Efficiency is doing an excellent job in raising this. Of course, for SMAC, that is the mobile air conditioner, there is no rating, but we found about 3, star 3. And higher the star, the better the rating, the less the power consumed. So if you have a 5-star refrigerator or a 5-star air conditioner, you are doing very well in terms of usage of your power. Your power bill will be less, and sustainability of the earth will be better. Of course, the rating is given by BEE. Window air conditioners has less stiff rating compared to the split air conditioners. A 2-star in window air conditioner, 2.7, will become only 1-star in split air conditioners. Because split air conditioners are used more, so they have become more strict than the split air conditioners. Also, this rating will change every 3 years or so that what was 2.7, a 3-star rating earlier, has become only 1-star rating. So Bureau of Indian Standards is giving very good support to sustainability. And Indian seasonal energy efficiency ratio is another definition of EER, where the overall performance of the unit for the whole year is taken into consideration all through the seasons. So efficiency is carried for the whole year. Then a comparison of a normal air conditioner and a split air conditioner, as I said, mobile air conditioner. Mobile air conditioner has got only, suppose if I use 0.75 or 1 ton or 1.2, 5 ton, it will have a constant power all through. Whether I put it in a small room or I put it in a very big room, it is only that. It is a spot cooler. It is a space cooler. Whereas normal air conditioner, it goes up with the load. So the load calculation is done. They say you require a 3-ton AC, then your bill will be higher. And we formulated the students and staff to come together and absorb the technology, learn the technology, and then develop the technology. These are the 3 aspects we have. So a second year student, he learns the technology, and then third year he absorbs the technology, and by 4th year he will be able to do some product for this kind of technology. This we implement in our institute. So we can do expected outcomes. We can first design using number of softwares like the top, studying the properties of refrigerant, school pack for the software for performance evaluation of the thermodynamics, AutoCAD for the design of the drawings, and then optimize the airflow through these designs, CFD analysis. All these are possible software the students help and staff help we can do. And innovative outcomes will come when a team is working. And some of the students who did projects like this was a horizontal refrigerator, then some technical people came evaluated, and then they were also published in some national journal. It means happiness to the students that as a technologist, they are doing very well. And then came the refrigerator, any refrigerator, air conditioner, compressor is the heart of it, and is the most expensive, and it is the most useful and tough part of the system. And there are different reciprocating, rotary, scroll. Scroll is the latest and more efficient. And open circuits like building air conditioners will use screw and centrifugal compressors. And when we make the product launch, we have to make a plan of say 1 month or 1 year or 2 years or whatever, depending on the seriousness of the project and also the severity of the project, the plan changes. And we have to do from plan analysis, build the prototypes, testing, reliability, trial production, freezing the design. So many aspects are there if you want to make a professional product for delivery to the market. As I said, some softwares can be used. And we studied different refrigerants for replacement from R22. From our point of view of sustainability, ODP, that is ozone depletion potential, and GWP, global warming potential, these two should be looked at. Now, most of the refrigerants have zero ozone potential, ODP, that is ozone depletion potential. R22 is still having 0.04, it will be replaced soon. And global warming, R134 is 1300 and R22 1500. So we have taken R134A as a replacement. There are others which are very low in global warming, but these are hydrocarbons. Hydrocarbons have flammability issue, and some countries are adopting, some countries are not adopting. So we are not going for hydrocarbons. The students are assembling the model. The top one is the evaporator. So what it does, it takes air from the room, it goes through the evaporator, cools it down, and brings it back to the room. So this air system is a closed circuit between the air. So it draws from the air from the room, and then gives it back a cool way to the room. Whereas the condenser, it draws air from the outside through the condenser, it makes it hotter and sends it back to the outside. So it's an open loop. And the refrigerant cycle is a closed cycle, that from the condenser it will go to the compressor. From the evaporator it goes to the compressor. From a compressor it goes to the condenser. Through the capillary it will come back to the evaporator. So it's a closed system. And there are a lot of technologies involved in building this, and how to brace tubes, how to check the brazing is leak proof, how to charge the gas, how much to charge the gas, and how to vacuum so that there's no, because you want your air conditioner refrigerator to work for 10 to 20 years. So there should not be a trace of moisture inside the tube when you are charging. So how to vacuum it. All these are technology of the refrigeration. As I said, we studied different thermal properties of the refrigerants using RefProp and then plotted them. And we found that suppose if you want R22, if you want a condenser temperature of, suppose if a condenser is operating at 300 psi, your enthalpy will be something about 110. And to get 110, you can operate R134 at only 200. So you are operating at a very low temperature, low pressure compared to R22. So R22 will be operating at 300, this will be operating at 200. So similarly, temperature graphs can be made. And we found that R134 is better in many fields, and in some aspects R22 is better. But overall balance is there between two gases, so we have taken. And when you design, you make a bill of material. Some of them you buy them, some of them you procure them. So how to procure, how much it will cost, how much power it will take, which is more efficient. So many aspects will be there, which students have to learn. And then we patented this, the whole body, there's no steel. It's all fiberglass body. The frame is fiberglass, the covering is fiberglass, the containers of space between hot and cold is also fiberglass. We made the molds, we got them made. So all this gave us technology. And we test them. When we test not only thermal point of view, even vibrations and noise, we did dynamic balancing and then static balancing. And we made a compressor. This is the mobile air conditioner bottom with the students. So they made, and we tested. And in one of the customers' test, this white one is the imported one, and this brown one is ours. So we made a comparative test of the temperatures and humidity test at different points in the room. And we demonstrated this in JNTU. There was a innovation zone. So we expressed it, and the number of professors came, and they were also happy that their affiliated institute has developed a product which is marketable. And we patented. Patent number is there, and an apparatus and a method for cooling and heating surrounding. For little bit improvement in the energy efficiency, we have patented this. And yeah, so all these aspects. Yeah, this is a patent application. Again, we displayed it in CIA also. We have displayed our unit. So there'll be a lot of learning. Like today is a technology day. From engineering to technology, a lot of processes are involved, and skills are involved, and students have to learn them. Today's students, it's not enough if they, during our time, if you had good marks, we had good placement. Today also sometimes it happens, but ultimately skill is most important. We have to understand how to transfer engineering to technology, learn the processes, learn the systems, quality systems, how to inspect, how to say your product is live and it can be shipped. If you have passed everything, when you ship it, it should not fail in the customer's place. It should have the reliability. So these are the aspects we have tried to learn, and then we can do better, but we are doing. And this unit is placed in a customer's place in James Street. The shop is fully stores. There's no window, there's nothing. Only he opens the shutter and his room is there. He does business from this table. And in hot summer, dirt and heat comes here. So earlier he had a fan, table fan there. So I sold him this unit, and he's quite happy that some cool air is coming compared to the hot air of the fan. Some cool air is coming, he's happy. And there's no window required, no wall required, because you cannot put a split AC, cannot put a window AC. After having done that for R22, along with Professor Gupta Garu, we have proposed for TechWip as a funding agency, international funding agency. We have put a proposal for developing R134A based, which is ozone-friendly refrigerant. So he came to our college, then he inspected our labs. This is the cyclometric lab at the back. It has an indoor test unit and the outdoor test unit where we do the testing of the units. Then Gupta Garu has seen our lab and they said, okay, we can build and we can make a proposal for tech to make a R1. Earlier it was a R22 based mobile air conditioner. So we proposed for a R134A eco-friendly, Montreal approved, Kyoto approved refrigerant. So we were going for that. So we made a proposal, and after the proposal, we got the project implemented, and we studied again different refrigerants, and we selected R134A, and we compared different aspects of thermal evaluation at different points, how it is comparison between R22 and 134A. Finally, we said that it is okay, it is equal, and the product is giving equivalent performance. So this conclusion, first mobile AC SMAC and Akela System Company is established inside Shreyas Institute. The company was made to manufacture these units, and some UG, PG, and PhD projects were going on. ISRE projects were taken and completed with students. And Akela System employees also supported industry for CAD, CAE models. We adopted Bloom's taxonomy level pedagogy, which we learn in this as a student. We adopted it for our industry also. And eco-friendly refrigerant 134A SMAC was developed. ER improved by heat transfer optimized condenser and evaporator. This was also patented, applied for patent. New heat transfer model used electrical vehicles. So because of our background of heat transfer, we are helping HBL to develop electrical vehicles where there will be heat of the batteries, motor, and controller. So how to remove that effectively, we are giving support to the HBL. So that's our project. So thank you, sir. I also have a small video of the student projects made. The time permits, I can show that.
Okay, sir.
One small 3 years. I don't know whether the audio will be. Incubation Center of Mechanical Engineering of Shreyas Institute of Engineering and Technology. Different products and development.
Sir, video is not audible, sir. If possible, please raise the volume.
Okay, sir. I stop.
Sir, raise the
Sorry.
volume, sir, if possible.
No, not possible. I think when we recorded, that voice is not coming to you. So there are different products which were made by students, but you got some idea. So that's the presentation, sir.
Oh, thank you, sir. Thank you, Professor Suresh Garu. It's a nice and wonderful presentation.
Gopalakrishna Garu is my colleague.
Is really very
That
useful.
is, I can see his face after a long time. Gopalakrishna Garu, namaskar.
Thanks, Institution of Engineers, for seeing you and hearing you.
Yes, sir.
Please share your contact details, Mr.
Yes, sir. Yes, sir. Yes, sir.
How is Mr. Dr. Venkateshwarlu?
This is not traceable, sir. For
Okay.
last 5 years, earlier he was in East Godavari, but suddenly maybe he went to his son's house in in USA. Maybe he went to USA. Nice seeing you, sir.
Well, happy days, Sriram.
Yeah, happy days.
Uh,
Thank you. Sir, any questions by anybody?
You tell please some words about this portable AC, which is recently coming to the market, and your office or address in Secunderabad, so that we can see it there.
Yeah,
Are you able to listen?
portable AC, as I said.
Portable, few words.
Yeah, it is movable inside the room. Suppose if you are having a drawing room, dining room, and kitchen, all are now attached, sir. You require 3-ton AC for the whole space to be cool. But why we should have it? Why should we cool the room? Why should we cool the room? We have to cool the person. I'm sitting in a room, only if I can have cool air on myself, that's enough. The space around me should be cool, not the whole room. So if I have a spot cooler nearby, that is mobile air conditioner, my area will be cool. So the room might be 10 by 10, 15 by 15, or 30 by 30. You are in a conference room, 30 by 30. The whole room requires 5-ton AC. Why should we do that? The chairman is sitting in a chair, and if that's the surrounding area is cool, that's enough. And maybe when a conference is happening, at that time you can switch on the total AC. Otherwise, the person can use only 1-ton AC is sufficient for.
Where can we see this physically? Secunderabad?
It is there, sir. In our college also, we made some prototypes and marketed. But
Contact address, sir.
we have to market them. Prototypes were marketed, but we have to go for total market. Internationally, some models are available, but in India, as I know, this was the first one. Maybe some others came later on, I don't know. This was the first model.
Sir.
Yes, sir.
Professor C, I am Professor Gupta.
Gupta garu, namaskaram.
Thank you very much for the nice lecture, sir.
Yes, sir.
What is the competitive price you can give for this portable AC, sir?
Around 18,000.
What is the capacity, that is tonnage?
1 ton, 1.25 ton.
1.25 ton, you can give it for competitive price of 18,000.
Yes, sir.
Okay.
We
Sir.
marketed 20,000, but competitive means some friends or somebody requests, we sell at 18,000.
Okay, sir. Thank you, sir. Thank you, Brahma Reddy garu, for arranging a good lecture.
Thanks, Brahma Reddy, for the interesting and useful talk on a great day. Happy to see all friends as Subhareddy and other people.
Mr. Ramana, sir. Hello.
Yes, sir.
Sir, good evening, sir. Suresh sir, बहुत बढ़िया है.
Thank you, sir.
Thank you. Dr. Ramana Martuna, very happy.
Yeah.
Sir, as
you are traveling, but you are also listening, sir.
Yes, sir. I am learning come learning and driving come talking, sir.
Driving come learning.
Sir, Suresh sir, in Sreya College and also JNTU, we have several meetings and conferences we attended. Sir, as Gupta sir said, I need of 1 or 2 that AC, sir. Sample AC. Is it possible to get it?
Yeah, sure. I'll be in
I'll
contact.
try tomorrow morning, sir. Thank you, sir. Thank you.
Thank
Good
you,
day.
sir. Thank you.
Good night, sir. Very good lecture, sir. So kind.
Thank you, sir. Thank you.
Sir, can you provide these portable ACs for our Institution of Engineers corporate members?
Why not?
Why not? Why not?
Sir, I need of 1 or 2, sir, kindly.
Yes, sir.
As Gupta sir said, for corporate members in a concession rate, kindly.
Yeah, this is the publicity for our portable AC to all the people.
Thank
Yeah,
you.
yeah. All of people means Gupta sir, those who needed and those who are
Obviously, because the needed one only will buy.
Yeah, మనకి ఇస్తుంటే గుప్తా ఇస్తే జేఎన్టీ మొత్తం ఇస్తుంది అట్లా మనకు ప్రపంచం దే నోస్ థాంక్యూ
Okay, thank you Subreddy garu and Professor Venkat
Subreddy
Subbaiah
sir.
for arranging this interesting lecture.
Yeah,
Thank you, sir.
Thank you all.
again happy National Technology Day to all.
Happy Technology Day.
Thank you.
Thank you, sir.
Sir, Professor Suresh garu, I think
Yes, sir.
రెండు పిక్చర్స్ వస్తున్నాయి సూపరండి 1 and 2.
ఏడు సార్
ఇక్కడ ఒకటి ఇక్కడ పక్కన ఇంకొకటి 2 people are there.
Subbaiah garu.
Uh,
So kindly, I'm having some other guests to leave.
Sir, Chairman, sir.
Kindly conduct the proceedings. I have some other meeting I have to leave.
Okay, sir.
Okay, sir. Thank you very much.
We have come to the end of this lecture, sir. So I am going to propose vote of thanks. So respected chief guest and speaker, Dr. Suresh Akella, Professor and Dean of R&D, Shreyas Institute of Engineering and Technology, Hyderabad, Engineer B. Brahmareddy, FIE, Chairman IEITSC, Engineer K. Subbireddy, FIE, Committee Member, IEI, Telangana State Center, and convener of today's event, council members of IEI, past chairman, past honorary secretaries, members, Telangana State Central Committee, IEI corporate members of IEI, distinguished guests, representatives of media, ladies and gentlemen. Good evening to all. On behalf of the Telangana State Center of IEI and on my own behalf, I convey our sincere and profound thanks to the Dr. Suresh Akella, Professor and Dean R&D, Shreyas Institute of Engineering and Technology, Hyderabad, for addressing the gathering as chief guest and delivering an excellent lecture relating about different refrigeration systems and air conditioners and relating them to the sustainability on this important day of National Technology Day. Sir, once again, I will extend my heartfelt thanks to Dr. Suresh Akella garu. I am grateful to past presidents of IEI, past chairman of IEI Telangana State Center, past honorary secretaries of IEI Telangana State Center, council members, committee members, corporate members, and others who made it convenient to attend this event. I also thank the representatives of media for their continuous support in covering the activities being conducted at our Telangana State Center. Thanks to one and all. Now I request all of you kindly stand for national anthem. Mahesh.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
जय हिंद।
Thank you, sir. I'm leaving.
Thank you, sir. Again, sir. Really, it is excellent lecture, sir. And
Thank you, sir.
Very well, you explained different types of air conditioning systems, sir.
Thank you.
Thank
I'm
you,
leaving,
sir.
sir. Thank you.